welcome to another class, and we're going to look at a topic in Form 3 known as approximations and errors, and it's a very interesting topic, and we're going to start with accuracy and errors, and we're going to do some definition here. An error is the difference between the actual and the measured value. So we are going to see that one in an example. Let's look at the types of errors that we have. We have number one, the absolute error. And when we talk about the absolute error, we are saying that this is half of the least amount of measurement, used unless otherwise stated. So that is an absolute error, and you can have an example here where the question says that what is the absolute error in 2.348 centimeters measured to the nearest thousandth centimeter, that is 0.001, the nearest 0.001. We want to find the absolute error, and we have said that the absolute error is given by the least amount of measure in that is being used. So in our case, the least measurement that we have here is thousandths, which is 0.001. So absolute error would be a half times the 0.001. You get 0.0005. That is the absolute error in that measure. So let's look at the type of error number 2, which is relative error. And relative error is given by the absolute error divided by the actual, that is the relative error. And then number 3 type of error, we have the percentage error, and the percentage error is given by the relative error multiplied by 100%. So we can have an example here. The mass of a metal is given to 14 kilograms to the nearest 10 grams. Find the percentage error in the measurement. So in this case, we can first ask ourselves what is the least amount of measurement, and in our case we have 10 grams. So the least measure is 10 grams. So you need to first get the absolute error, which is given by the half times the least amount of measure, which is 10 grams. You get 5 grams. Then you want to get the percentage error. Percentage error, we need to get the relative error, and then relative error, of course, is given by the absolute error divided by the actual measure. So this is going to be 5 grams divided by 14. The measure was 14 kg. And then we're going to be having here relative error is going to be 5 grams over 14 kg, which is 2 grams. You get 14 times 100,000, you get 14,000. That is the relative error. You can simplify. And then the percentage error is going to be the relative error, which is 5 over 14,000 times 100. Can simplify that, and this is going to give you 5 over 140, which is equivalent to 0.03571. That is to 4 significant figures. So let's look at another example on the percentage error. So the thickness of a coin is given as 0.20 centimeters. What is the percentage error in that measurement. So in this case, you need to first ask yourself the absolute error, and absolute error is given by the half times the least measure. So our least measure here should be 0.01. That is the smallest measure that you can get from that. So get half times 0.01, and this is going to get 0.005. That's the absolute error. Then we have the relative error, which is given by now the absolute error divided by the actual measure. And then the absolute error in our case, we have 0.005 divided by the actual measurement, which is 0.20. And then we want to get a percentage error. Percentage error is given by now the relative error is 0.005 divided by 0.20 times 100%. And this one we are going to get as 2.5%. 2.5%. So let's look at error type number 4, and we have the loud off error. So when we talk about the loud off error, we're saying this is the error that occurs when a number is louded off. So when you are in a process of louding of a number, then you're going to occur an error which is going to be referred to as the loud off error. Let's see an example here. What is the loud off error when 1.6 recurring is louded off to two significant figure to become 1.7? So we have say our number here as 1.6 recurring, which is given, which is 1.6666 going forward like that. It is louded off to two significant figure to be 1.7. We want to see the error that the loud off error that is going to occur. So the first thing is to change this number to fraction form so that you can see the actual number that it is, and of course you can multiply by it. So we have our R here is 1.6666 carrying, then get 10 R multiply by 10 on both sides, get 16.6666 like that. So you subtract the two. First equation, it's 2. So 10 minus 1, you get 9R is equals to now 16.66 minus 1.66. Of course, this one I'm going to cancel, and then this one is going to be 16 minus 1, you get 15, and then our R will be divided by 9 on both sides, 15 over 9, which value, if you simplify this one by 3, get 3 by 3, 5. So 5 over 3 is our 1.6 carry. Then we want to see the loud off error. So the loud off error will be given by, which you can refer to as now the absolute error here. In this case, it's going to be now the actual, which is 5 over 3. You subtract the number that you have gotten after rounding off, 1.7, is same as 17 over 10, and then you give the absolute value of that. Don't consider the sign. So the LCM here is going to be 30. That divided by 3, you get 10 times 5, you get 50, minus that divided by 10, get 3, then 17 times 3, you're going to get 1 carry 21 to 1 carry 2, 3, 5. So get 51 over that. So in this case, we have 50 minus 51, get minus 1 over 30. But what the absolute value? So you get 1 over that as the absolute error in that case. Let's look at error number 5, type of error that we have. And we have the truncation error. And I talk about the truncation error. You're saying this is an error that occurs when a number is truncated. And you can have an example here so that you can go to see how the error occurs. So we have a question. A John truncated 7/9 to 3 decimal places. Calculate the percentage error resulting from truncation. So we have the number is 7/9. This one is truncated to 3 decimal places. So the first thing is to write this number into decimal form. 7/9 is going to be so 7/9 is given as in decimal form. You get 7 divided by 9, 7.70. You get 7 cos of 63, divided by 7, 7 cos of 63, 7 cos of 63, 7 cos of 63. So 7/9 is equal to 0.77777 carrying. But this number is truncated to 3 decimal places. So talk about the truncation, just cut the three decimal places. In this case, 1, 2, 3. You cut the number at that point. So our number is going to be now 0.777. That is the truncated value. Now we want to get the percentage error resulting from the truncation. So the first thing is to get to the truncation error or the absolute error, and truncation error will be given by, or about the absolute error, the truncation error will be given by now the actual value, which is 7/9. Subtract the truncated value. 0.777 is given to 777 divided by 1,000. So write it here, 777 over 1,000. And the LCM of these two is 9,000. Divided by 9, you get 1,000 times 7, you get 7,000 minus 9,000 divided by 1,000 is 9 times 777. You get to have 6993. And this one you're going to be getting an absolute value of that one. So 7,000 minus 6,993, that is going to be 7/9,000. So that is the truncation error or the absolute error. But we are being asked to get the percentage error. So in this case, the percentage error will be the relative error times 100. And the relative error is given by the absolute error. You divide by the actual value, which was 7/9. And then this one is multiplied by 100. This is going to be 7/9,000 times 9/7, then times 100. So by 9/9,000, by 7/7, 2 zeros goes. So that is 1/10, which is equal to 0.1%. So that is the percentage error. Let's look at our last example for the first part, which is now a question from the KCSE 2017. It was in paper 2, question number 2. The question reads that a tailor intended to subdivide a piece of cloth into 7 equal parts. She approximated 1/7 meters to 0.14 meters. Calculate the percentage error in the approximation. So the first thing here to do is to get the absolute value, absolute error. and absolute error is going to be given by now the actual value 1/7 is subtract the approximated value of 0.14 and we get the absolute value of that. So this is going to be 1/7 subtract 14, 0.14 in fraction over 100, the absolute value. Don't consider the sign. It's going to be a LCM of 7 and 100, that is 700. 700 divided by 7, you get 100 times 1, get 100 minus 700 divided by 100, you get 7, and 14 times 7, I'm going to have 28, carry 2, this is going to be 7 plus 2, 9, so that is 98. So the value there, 100 minus 98, is going to be 2/700. This one, of course, you can simplify to be by 2 and by 2, 350, 1/350. So that is the absolute error in our measurement. So we want to get the percentage error, and the percentage error is given by the relative error times 100. So the relative error here would be the absolute value 1/350. We divide the actual value, which is 1/7, and then times 100%. So it's going to be 1/350. Then divide 1/7 times 7/1, then times 100 by 7, 1 by 7 are 50. Then that one is going to cancel by 5, 1 by 5, 2. So you're going to get 2%. So that is the percentage error in that measure.